Introduction to Software Engineering. Contents: What is software? What is software engineering? What is the difference between software engineering and computer science? What is the difference between software engineering and system engineering? What is the software process? What is the software process model? What are the costs of software engineering? What are software engineering methods? What is CASE, computer-aided software engineering? What are the attributes of good software? What are the key challenges facing software engineering? What is software? Computer programs and associated documentation such as requirements, design models and user manuals. Software products may be developed for a particular customer or may be developed for a general market. Software products may be generic, developed to be sold to a range of different customers, e.g. PC software such as Excel or Word. Bespoke, custom developed for a single customer according to their specification. New software can be created by developing new programs, configuring generic software systems or using existing software. What is software engineering? Software engineering is an engineering discipline that is concerned with all aspects of software production. Software engineers should adopt a systematic and organized approach to their work and use appropriate tools and techniques depending on the problem to be solved, the development constraints and the resources available. What is the difference between software engineering and computer science? Computer science is concerned with theory and fundamentals. Software engineering is concerned with the practicalities of developing and delivering useful software. Computer science theories are still insufficient to act as a complete underpinning for software engineering, unlike e.g. physics and electrical engineering. What is the difference between software engineering and system engineering? System engineering is concerned with all aspects of computer-based systems development including hardware, software and process engineering. Software engineering is part of this process concerned with developing the software infrastructure, control, applications and databases in the system. System engineers are involved in system specification, architectural design, integration and deployment. What is the software process? The set of activities whose goal is the development or evolution of software. Generic activities in all software processes are specification, what the system should do and its development constraints, development, production of the software system. What is the software process? The set of activities whose goal is the development or evolution of software. Generic activities in all software processes are specification, what the system should do and its development constraints, development, production of the software system. Role/action perspective. Who does what? Generic process model. Waterfall, iterative development, component-based software engineering. What are the costs of software engineering? Roughly 60% of costs are development costs, 40% are testing costs. For custom software, evolution costs often exceed development costs. costs vary depending on the type of system being developed and the requirements of system attributes such as performance and system reliability. Distribution of costs depends on the development model that is used. What are software engineering methods? Structured approaches to software development which include system models, notations, rules, design advice and process guidance. Model descriptions of graphical models which should be produced. Rules constraints applied to system models. Recommendations advice on good design practice. What is CASE? Computer-aided software engineering software systems that are intended to provide automated support for software process activities. CASE systems are often used for method support. Uppercase tools to support the early process activities of requirements and design. Lowercase tools to support later activities such as programming, debugging and testing. The software should deliver the required functionality and performance to the user and should be maintainable, dependable and acceptable. Maintainability software must evolve to meet changing needs. Dependability software must be trustworthy. Efficiency software should not make wasteful use of system resources. Acceptability software must be accepted by the users for which it was designed. This means it must be understandable, usable and compatible with other systems. What are the key challenges of facing software engineering? Heterogeneity, delivery and trust. Developing techniques for building software that can cope with heterogeneous platforms and execution environments. Delivery. Developing techniques that lead to faster delivery of software. Trust. Developing techniques that demonstrate the software can be trusted by its users. Professional and ethical responsibility. Software engineering involves wider responsibilities than simply the application of technical skills. Software engineers must behave in an honest and ethically responsible way if they are to be respected as professionals. Ethical behavior is more than simply upholding the law. Issues of professional responsibility. Confidentiality. Engineers should normally respect the confidentiality of their employers or clients irrespective of whether or not a formal confidentiality agreement has been signed. Competence. Engineers should not misrepresent their level of competence. They should not knowingly accept work which is out with their competence. Intellectual property rights. Engineers should be aware of local laws governing the use of intellectual property such as patents, copyright, etc. They should be careful to ensure that the intellectual property of employers and clients is protected. Code of ethics. Preamble. The short version of the code summarizes aspirations at a high level of the abstraction. The clauses that are included in the full version give examples and details of how these aspirations change. The way we as software engineering professionals. Without the aspirations, the details and become legalistic and diluted. Without the details, the aspirations can become high-sounding but empty. Together, the aspirations and the details form a cohesive code. Code of ethics. Principles. Public software engineers shall act consistently with the public interest. Client and employer software engineers shall act in a manner that is in the best interests. Product software engineers shall ensure that their products and related modifications meet the highest professional standards possible. Key points: software engineering is an engineering discipline that is concerned with all aspects of software production. Software products consist of developed programs and associated documentation. Essential product attributes are maintainability, dependability. The software process consists of activities that are involved in developing software products. Basic activities are software specification, development, validation and evolution. Methods are organized ways of producing software. They include suggestions for the process to be followed, the notations to be used, rules governing the system, descriptions which are produced, and design guidelines. Case tools are software systems which are designed to support routine activities in the software process, such as editing design diagrams, checking diagram consistency and keeping track of program tests which have been run. Software engineers have responsibilities to the engineering profession and society. They should not simply be concerned with technical issues. Professional societies publish codes of conduct which set out the standards of behavior expected of their members. End of the course. Thank you.